This is 4.5 exponential and logarithmic equations. So here we're going to solve equations using logarithms and the exponential properties that we were referring to in the last couple lessons. So the only way to solve some equations is using logarithms. And so if we look at 5 to the x power equals 125, just let me remind you, there's a couple ways to do this actually, but remember 125 we all know is 5 cubed. And so notice if this is 5 to the x power equals 5 cubed, that means x has to be 3. And the same thing here. Notice the base is 5, the base is 5, which implies that the exponents are going to equal one another as well. And so when you solve this, you're going to get x equals 1. So let's look at something like this. Here we have 3 raised to the x plus 2 power equals 7. And the question is oftentimes, well, how do I get the variable? How do I solve for a variable that has the x in the exponent? Well, one of the things that you've always been taught since Algebra 1 is what you do to one side of the equation, you have to do to the other side. Well, what we're going to do is we're going to use logarithms. We're going to literally take the log of both sides. And if you apply the properties of what you have here, for the properties of logarithms, remember what to do with the exponent. That's the same thing as if I bring it out to the front. And remember, keep in mind, I'm trying to solve for x. Keep that in mind. So to get rid of, we're going to divide both sides by log 3. And then we're just going to minus 2. So negative 2 plus log 7 over log 3. And we're just going to plug that into the calculator. And when we plug in the calculator, we're going to get negative 0.2288. And that's the value of x. I mean, you can always check it. If you plug that value back into x, and then add 2 to it, and then 3 to that power, it should equal 7. Or again, since this is a rounded decimal, it will come very close to 7. All right, so if we look at this, what we want to do is solve this one, and this one happens to be, I had to pause the video because I forgot the letter E in the problem. So 8e to the 2x power, and what we're going to do is solve this. Again, we're trying to solve for x, so keep that in mind. So let's first get rid of the 8, so we're going to divide both sides by 8. And then if you remember, one of the things that we talked about, one of the properties with the e, to get rid of that, the inverse function is ln. So we're going to literally take the ln of both sides. So literally ln this side, ln this side. And that's literally going to cancel that out, and you're left with 2x. And then we're just going to divide both sides by 2. And then when you plug this into the calculator, you're going to approximately equal 0.458. All right, so let's look at this one. E to the 3 minus 2x power equals 4. And again, anytime you see an E, it's a good clue just to ln both sides. So we're going to ln, and it's literally going to cancel that out. So 3 minus 2x equals ln 4. And let me just remind you guys, if you plug ln 4 into the calculator right now, you're going to get a decimal. Make sure you don't round. Never round in the middle of a problem. That's why I keep it until the very end. I'm going to keep writing ln 4 until the very, very end, and then get my final answer. So here we have negative 2x equals ln 4 minus 3, and then we're going to divide everything by negative 2. And when you calculate that, you're going to end up getting approximately 0.807. All right, so let's look at this one. This one may throw you for a loop a little bit, because when you stare at it, it's a trinomial, and you're like, whoa, it's an e to the. Well, what I want to remind you, if you notice, there's sort of a similarity. If I had x squared minus x minus 6 equals 0. And there's sort of a similarity, because I really have, I really have e to the x but it's being squared. And then minus e to the x minus 6. So notice the similarity, and if we factor this would be x minus 3, x plus 2. And so that's what we're really going to do here. We're going to factor this, and we're going to have e to the x, e to the x. Again, e to the x times e to the x is e to the 2x. And then we're going to have literally the minus 3 and the plus 2. And then you're going to set each of these equal to 0. So e to the x power equals 3. To solve this, again, you can ln both sides. So x equals ln 3, which is approximately, if you plug that into your calculator, it approximately equals 1.0986. Here we have e to the x equals -2, and here we could stop, because if you remember the e function, if you graph it, it doesn't cross. If you remember the asymptote, it doesn't cross into the negative range. So this cannot have. There's no x value that will ever make that to be a negative answer. So this part is, you just kind of ignore that because that's impossible. You can't have an x value that will reach that. So the only solution is 1.0986, and that's an approximate value for that. All right, so let's look at this problem right here. Here we have a combination of a big log problem on the right side and then the left side, but what I want to do is use my log function. So notice this right side and notice the plus sign, and I'm going to kind of combine those together to literally be x minus 2 and x plus 3. Remember that this means the same thing. Remember the property of the log AB equals log A plus log B. And so all I did was I went backwards and I'm going to combine them together. And so over here we have log x squared plus 1. And both sides have logs, so that just means the left side x squared plus 1 is the same thing as x minus 2, x plus 3. And now I'm just going to solve this. So if I multiply those out, you can see the x squareds are going to cross out. And then x equals 7. And as always, math teachers always say this, always check your answers. If you have extra time on a quiz or a test, go back and check that answer 7 into those x's and see if the left side equals the right side. All right, so let's look at a couple more equations for solving log functions and solving for the variable x. So here I have ln x equals 8, and again, the same thing as to get rid of an ln or what we did already to get rid of an e, we're going to do the inverse of that. So we're going to literally e both sides, and so the e and ln are inverse functions, so x equals e to the 8th power, and then you're just going to plug that into the calculator to get approximately 2,981. All right, so this one right here, if you notice what we're going to do here, if you notice we're going to do exponential, write in exponential form, so 2 to the 3rd power equals 25 minus x, and of course that's 8 is 25 minus x, and then you're going to solve for x and get 17 as your answer. So let's look at our last problem. So here I have a log, and again I have plus, I'm adding the two logarithms, so that means I'm going to combine them together. Now this next step is the crucial part. Remember the base here is 10, and so literally I'm going to do 10 to the 1st power equals this. And notice I multiplied that out, I FOILed all that out. So that step is the crucial. You might want to pause the video, make sure you understand that, so that it got rid of the log. And I want to get rid of the log, and I just did that by writing it in exponential format. So 10 to the 1st, go counterclockwise, 10 to the 1st, which is 10, and then equals x plus 2, and then times that by x minus 1. And then we're going to solve that. Now, when you get down to this step, I've said it a couple times in this video, but teachers have always said it, make sure you check your answer, especially with logarithms. Because sometimes, even though I've got two answers, sometimes it can't actually happen. So if you actually go back and plug these values in, you're going to see something. So here, if I checked x equals -4, if I put -4 inside of here, that's going to give me -2. And you can't have logarithm of negative numbers. You try to graph it or try it on your calculator or try to calculate that, it does not exist. If you remember the function for logarithms, it looks like this. So, you don't have any numbers over here on the negative side. You can't evaluate logs on the negative side. Now, something I do want to, in x equals 3 does work, so that is the only answer. But something I want to emphasize, just because you get a negative answer for x, don't always assume that it's wrong. You actually have to plug it in to see if that is still going to make a negative log. So for instance, if this was something like x plus 5, well, -4, if I plug -4 inside of there, I will end up getting log of a positive number, so this would still work. So you have to be very careful and make sure that, check your answers, especially, something that will end up being log of a negative number. I can't have that, all right? So make sure you check the values. So here, in this case, that does not work. The answer is x equals 3. And that's how you solve exponential and logarithmic equations.